Hello and welcome. We're really excited to have everyone here today for our weekly OCI deep dive. And of course, we invite you to create a free account, join in discussions, and look for upcoming events on all kinds of topics. I'm Zaid, Product Marketing Manager with OCI Go to Market Strategy Team. And today, we're joined by my colleague, our presenter, Ismaël Hassane. Ismaël is a Lakehouse and Analytics data specialist, part of Oracle EMEA Technology Engineering team. We also have Jose Cruz. Jose is a Lakehouse and Analytics data specialist leader, part of Oracle EMEA Technology Engineering team. Jose will help us with the Q&A. Together, they'll walk us through OCI Data Lake Modernization. They'll cover the following topics: data lake definition, why and how to modernize, quick hands-on demo of OCI Big Data Service, or BDS.
Great, thank you very much. So before I start with the introduction, introducing myself and so on, I would like to quickly comment the result of the poll. So the first question was about the challenges of the data lake. And I can see here that the main one that you have selected here is data quality. And then in second, we have data accessibility, governance. So I believe on this one, we are totally aligned, and this session will reflect just that, and we will try to address this main challenge of the data lake. And on the second one, the question is more about the tools that you're familiar with. So I can see here that you're familiar with identity and access management, you're familiar with streaming, and the big data service. So yeah, this is great. And now I will start with the actual session. So for today's session, we're going to discuss data lake modernization. So again, at Oracle in general, our focus, or here is our mission statement, it is to help people see data in new ways, discover insights, and unlock endless possibilities. And it is exactly what we are going to do for today's session. So it will be all about big data. I can see that you're familiar with this topic. It will be about Hadoop clusters, data ingestion and processing. It will be also about analytics, data science. We will discuss high availability, scalability, data security, identity and access management, and data governance. So if these are of interest to you, you are at the right place. So again, as introduced by Zaid in the beginning of this session, myself, I am Ismaël Hassane, and I am a Lakehouse and Analytic data specialist. So I will present this session to you. And today I'm fortunate enough to be or to share the stage with the leader of my specialty, Jose Cruz. So he will be in the Q&A. So do not hesitate, throw in your tough questions. You are in good hands. So moving forward, before I actually start the presentation and present the agenda and move forward, I would like to take a second in here to share this information with you, that basically I will have two demos, and the second one is about a product that is still in limited availability. So by the way, we are hiring volunteers who would like to try out this new technology. So do not hesitate, reach out to us, and we will whitelist your tenancy to try it out. So let's go. Here is our agenda for today. So it basically has three main points. So the first one is all about defining the data lake. What is the data lake? On the second point, we will see what are the drivers of a data lake modernization. And finally, we will see how to modernize. So exactly how to modernize, which technology to go with. Great. So let's get started with the first point of our agenda. What is a data lake? So a data lake, basically, it's a repository for structured data, semi-structured data, and unstructured data. This data can be produced at any size, it can be of any format, and it can be delivered at any scale. However, it remains important that this data is retrieved easily and is also possible to be analyzed in the most convenient way. So let's visualize together what the data lake look like. Basically, you can focus on the view we have on the right-hand side of the screen. So we can see that the data, it can come from various sources. This can be enterprise applications. So basically, for example, your CRM or your ERP. where you have data of high quality, which is governed and so on and so on. The data can also come from digital assets. It can come from sensor data. It can be data that will be streamed as events, or it can also be produced by your business users. So all of these data sources, as you can see here, they can reside anywhere. It can be on premises in your private data center, or it can be hosted by a cloud service provider. This data can also be mobile in the sense that it's delivered by an IoT device. So it's changing location permanently, for example. This data is heterogeneous by nature in the sense that it comes from various sources and it has to be consolidated in the data lake, and this with respect to different approaches. What are those approaches? Here I'm mainly talking about data processing and data ingestion. So as we can see here, this ingestion can be done in the form of batches. That is to say that the data is ingested in chunks. So you take a certain amount of data and you ingest it, transform it, ingest it in your data lake. And this can be done at a predetermined frequency. So this frequency can be on, let's say, every hour, every day, every week, or even with a data-driven approach. So basically, when the data is available, then you process and ingest it into your data lake. This data ingestion process can also be something that will be streamed. So as the data is being produced, it's automatically being processed and ingested in your data lake. That is the lower end of this diagram that we can see for batch processing, and on the higher end, we have the stream processing. So this data, once you have it in the data lake, the idea is not to just sit on it. The main goal that we have as a business usually, or an organization in general, is to consume this data. And those data consumers are usually data warehouse users. It will be for analytics purposes. It can also be for artificial intelligence and machine learning models. So basically for the training and the prediction that these models will be responsible for. And finally, in terms of data consumption, sometimes the goal is just to share the data with your various stakeholders. So an important thing in here that you have on the lower end of this view is the security and governance layer. So I'm very happy that in the poll you have responded that data quality is one of the main issue. So I believe this will be reflected in terms of governance and security on top of the capability to process the data and make sure that it's of high quality. So this is it for the definition of the data lake. I wanted to keep this one short, so we will have more time to go about talk about the migration to your OCI cloud infrastructure. So basically now we're going to see why to modernize, what are the main drivers of your data lake modernization. So we have mainly three reasons. The first one can be a data center exit. So basically your organization makes the strategic decision to move away from all on-premises deployment, and this can be for various reasons. Oftentimes it will be for cost-saving reasons. So basically you want to move away from these capital expenditure models where you have to make a huge amount of investment beforehand before you derive any value of your data lake. And moving on the cloud will allow you to actually make sure that the expenses are exactly linked to this value you're deriving, because you're now in a different model, which will be an operating expense model. And also another reason here for this cloud mandate can be to take advantage of the resilience that the cloud infrastructure will provide, apart from other benefits such as you don't have to manage the infrastructure, you don't have to deal with, let's say, electricity bills of your data center, and so on. The second driver that we often see when it comes to modernizing your data lake is to do a cost optimization. So basically you will target a compute or resource intensive workload that is currently running on your private data center, and you decide to migrate this to the cloud. So it can be, for example, you target your big data cluster that's currently running on premises and you decide to move it to the cloud to take advantage of the cloud model and all of its benefits. A last reason that you can target in here is the full cloud native migration. So basically, let's say, a rationale in here to pursue this approach is that you basically sit and really assess your data lake. So your findings is that your data lake is no more, let's say, of use. It has turned into a data swamp in the sense that your data is completely ungoverned. It is hard to find. It is impossible to analyze. It is difficult to manipulate, and it becomes the source of inaccurate information. And we know that data is supposed to be, or it's let's say, it's the new oil. So it's important that it remains of high quality. So basically, in this third scenario, you can no longer trust your data lake. And yeah, in here, the best option is to start, like restart on new grounds, and then just decide to go on cloud native migration. So this is it about the drivers of the data lake modernization. Now back to the agenda again, and this is on this third point that we will spend the most time, and it's all about how to modernize. So how to modernize your data lake, we will basically explore three options or three steps in terms of migration roadmap. The first one will be to replatform. On the second one, we will try to refactor the data lake. So basically, after you have migrated to the cloud, you will try to position cloud native components. And finally, it's more in the case where you want to directly target the latest innovation that's running in the cloud, where you don't have to manage anything and where you can take advantage of all the cloud business model in general. So let's explore the first option, the replatforming. So the replatforming, basically, what is it? In this specific case, the idea is that you have a Hadoop cluster, for example, running on premises or with a third-party cloud provider, and you would like to move away from that, and you want to go on a cloud where you don't have to manage all the infrastructure, where you can take advantage of infrastructure scalability, of resilience, where also the cloud provider is taking the responsibility for the management of this infrastructure that is behind. Your goal here will also be to have something that is more enterprise ready, where in terms of security, data governance, and integration with the cloud provider ecosystem is in there. So about the replatforming, how can we do this when it comes to the Oracle Cloud Infrastructure? We have a service that is doing just that. It's called the OCI Big Data Service. And basically with this service, you can have a like-for-like migration. You take your Hadoop cluster and you migrate it to the Oracle Cloud Infrastructure Big Data Service. So let's see what this service looks like. But before I go in there, just a quick information in here is that let's assume you migrate your workload to the cloud, but the data sources or the data consumption layer remains on premises. You can take advantage of our Fast Connect, which will allow you to have, these private bandwidth where you can connect your on-prem resources with your cloud resources and have a bandwidth that will be reliable to be able to, move data between these two data centers. So a few words about our big data service. So because it's core and center of this first replatforming option, we will explore some details about this service. So what is the big data service on the Oracle Cloud? It is, again, a cloud-based platform that allows organizations such as yours to process data and analyze large volume of data. So it uses an Oracle distribution of Hadoop, and you have all of the major, let's say, Hadoop components, and this includes Spark, Hive, Presto, Kafka, HBase, Jupyter, and so on. You have everything that you will have otherwise in your on-premises cluster. So this means that you can leverage all of these tools to process your data and extract valuable insights. So furthermore, this big data service is enterprise ready in the sense that it comes with features such as an integration with Active Directory. It is highly available. It has a patch management feature. It also comes with bootstrapping scripts, which will allow you to tweak your environment in the exact direction you want it. It also comes with auto-scaling features. So in here, you can have vertical auto-scaling as well as horizontal scaling. It has an integration with OCI object storage. I will provide some more details about the object storing later on. And it also has an integration with Kerberos for the security features. So basically with this service, you are confident that you can move away from your current data center or your deployment big data clusters on premises to the cloud, knowing that you have kind of a like-for-like migration. And again, you're taking advantage of the advantages of being on the cloud. So yeah, now let's move forward. What does the big data service looks like if we go with a logical view? So basically, you can see that you have various technologies. Here I have organized them in terms of, let's say, the exact function we're expecting them to deliver. So we can see here you have all of this, and most of them are coming from the open source community. And what the service is actually delivering is the infrastructure management and this extra layer of security and governance on top, apart from the integration with the other services of the Oracle Cloud in general. So without going too long about this product with just a slide deck, I will move on and present you the service and see what it actually looks like. So in terms of demo flow, this is what we will see. We have the big data service in the middle, and then you will see that there are various compute shapes that you can take advantage of. Basically everything that is on the Oracle Cloud. We have various storage options, and you can choose cluster profiles to tweak your clusters in the exact direction you want based on the function you're expecting this cluster to deliver. So yeah, without wasting more time here, I will move on and connect to my Oracle Cloud infrastructure console. So just refreshing this to avoid being locked out. It's coming. Let's see, maybe I will have to log in again. Okay, it's there. Perfect. So now that I have my console that's open and running, I will start and go on the big data service. So basically, to get to the big data service, you have to go in the hamburger menu, select Analytics and AI, and you have it here under data lake. So it's the first option. We select the big data service. So now it's open. So quickly to show you how to create a cluster, it's completely easy. The first option is, you come here on this screen, you select the compartment where you want to deploy your cluster, and you click on create cluster. So by the way, everything I will do here, by clicking with this graphical interface on the console, everything is available as APIs. So you can automate all of this process. Okay, so let's move forward. So basically, to create your big data service cluster, you just have to specify some few things, such as the name of your cluster. You have to provide an admin password. And we can see here that you have this simple option where, by clicking on this, you can decide that you want a secure deployment. So the secure deployment means that it comes with extra security features, for example, in a Kerberos integration. And also it allows you to have this high availability. So we will see what it means later on. Moving forward, you have the cluster versions that you can choose. So basically here, in terms of Oracle distribution of Hadoop, we have up to these 3 versions. And one thing to keep in mind is that this service has been built to allow you to really easily migrate away from your on-premises or third-party cloud provider deployment of your cluster and come to OCI. That's why we're maintaining slightly older versions as well. It's to offer you a smooth migration. So apart from this cluster versioning, we have also the cluster profiles. So basically, what is it? You can see we have Hadoop, we have HBase, Hive, Spark, Kafka. Because usually you don't provision your big data cluster to use all of the services. So in here, we allow you to really, pick the infrastructure beforehand and the settings that will allow you to really derive the best value based on how you're using your big data clusters. So here, let's assume that I select a Hadoop profile. I will move forward. And now we can start specifying the exact compute that we want. So basically here, for the first option, I can choose my master and utility nodes. And here we see we have 2 options. So the first one is the bare metal here on the right-hand side. So the bare metal, what it means is that you have a physical compute that will be assigned to you. So you are not sharing it, and it's not. It's really a physical computer that is assigned to you directly. And the second option we have here is the virtual machines. So in terms of virtual machines, we can see we have various options. Again, we have those standard shapes, but we also have these flexible shapes. And what is the advantage of the flexible shape? It's basically that you can, decide to assign the exact number of CPUs and also the memory that you want. So you basically define the exact compute you want. Here you have the option also to choose the amount of block storage to allocate to this virtual machine. So as you can see here, we have one option that is dedicated to master and utility nodes, and then later on you can specify the compute shapes of your workers node. So they do not have to be the same. You can just tweak these to make sure that you have the compute capability necessary to process your data. And the same options are true in here. You have all these different compute shape that you can choose from. And also an interesting point here to note is that you have this dense IO, which comes with NVMe SSD attached to this compute shapes. So you can choose also here, important point, the number of nodes, of workers node. So moving forward, you have to specify the network settings where you basically want these resources to be running. And after you choose this, then you have an option for encryption. So basically, all of your data, you can choose to rely on Oracle managed keys to encrypt your data, or as a user of the Oracle Cloud, you can bring in your own key and use the key vault. And here I was mentioning early on the bootstrapping scripts that will allow you to tweak, your environment with shell scripts to make sure that these compute environments have the exact settings that you're expecting them to have based on the profile and how you're using your big data cluster. So for the purpose of this presentation, I will not create this cluster. I have one that's already active. Okay, maybe I should show you this before. Just as information, we can see here on this screen, we have the state of my cluster. We have the number of nodes. I have this option, secure and highly available. So yes, I have selected that option when I was provisioning my cluster. And we have the version here and the date of creation. So if I go in this big data cluster that I called big data cluster, BDS cluster, we can explore some more things in here. Namely, we can see all of these utility nodes, 1, 2, we have the worker nodes, we have the 3 of them, and we have the master nodes. So something important here that I want to mention to you is that I have selected the high availability option. So how we can verify this, it will be with, let's say we consider these 2 utility nodes. They will basically be spread across different compute capabilities. So let's see, I selected this first one. So if you pay attention here in terms of availability domain, and also the region. So we can see here it's in the Ashburn region, and it's on the availability domain 1 and the fault domain 3. So now we will consider the second utility node and see if it's deployed in the exact same place or not. So here we see it's different. It's still in the Ashburn region, but it's deployed on the second availability domain, and this one takes advantage of the fault domain. So based on the region where you deploy your resources, you will either have you will either take advantage of the availability domains if you have a multi-availability domain region, or you will rely on the fault domains that are in a single availability domain region. So this is it about the short demo I wanted to present to you. So now let's go back to the slide deck and move forward and consider how to actually do the migration. So for the migration, it's 3 short steps. The first one, you back up the existing Hadoop cluster that you have in terms of data and metadata. You back all of this into the OCI object storage. And then you create your big data service cluster as we have just seen it together. And finally, you restore all of this backup into the big data service that you have just provisioned. And in terms of tooling, you can use a combination of either distributed copy or Hive metadata migration. Otherwise, the other option will be to go with OneDisco. And you can target one disk if you have, let's say, some complex migration, as you know, you want to have these two systems that are live. You don't want to have any downtime. For example, you have other options that are here on the slide. So now we will move on to the second approach when it comes to migrating, or how to modernize basically your data lake. So here, as you can see, it builds up on the first approach. So basically, after you migrate to OCI Big Data Service, you can start co-locating with cloud native services. So here, the services that we want to position in here are, for example, OCI Data Flow, which is the Oracle managed version of Apache Spark. You want to position OCI Streaming, which is, you know, a version of Kafka that is managed by Oracle. You don't have to deal with the infrastructure. And you want to position tools as well, such as OCI Data Science, Analytics Cloud, Autonomous Database, and so on. And basically, the main component in here that will allow you to do this is by positioning the OCI object storage, because it has integration with all of these services, the services in red on the screen. And how are you able to, you know, make sure that those applications provisioned with the OCI Big Data Service are able to communicate with the OCI object storage? It is by positioning the HDFS connector for object storage. So basically, with that, all of your application, let's say your Spark cluster or your Kafka, will be able to read and write from OCI object storage. So let's see, OCI object storage. Why will we want to position OCI object storage next to our HDFS? So basically, because it's cheaper. It's an internet scale storage layer that is cheaper than the block storage where your HDFS will typically run. And it comes in three tiers. So you have you know, this possibility to archive the data based on the exact life cycle where the data is in it. So the first option will be the active data. So basically, to do your big data analytics, you can store all of your data in this active data layer, which we call standard. Or if it's data that you do not frequently need, for example, you know, the backup that you have done of your big data cluster on premises before you provision your or before you actually do your migration on OCI, you can use the infrequent access to store this backup. And finally, you have the archiving layer. And overall, you can use policies to automate how this data move across these layers based on, you know, the usage, for example. An important thing here to note on the object storage is the durability. Apart from being a regional level service, in terms of durability, we have up to 11 nines, which means that the probability of losing one object out of 1 million is basically the risk of losing one object out of 10 million in 10 years is 1. I hope this is clear. So moving forward, another tool that we'll position, as said before, you can position OCI data flow. You can collocate this and have it process some workload that would otherwise be affected to Apache Spark. So why OCI data flow? Basically because it's our OCI managed version of Apache Spark. And the advantage here is that you don't have to manage any infrastructure. So Oracle will handle that. You will just have to, you know, submit your code, and we make sure that we process the data against this code that you have submitted. In terms of languages that are supported, OCI data flow supports Java, Python, SQL, and Scala. And apart from being this, you know, this code-based ETL where you process data in batches, it also have an option where you can do Spark streaming, and so the data will be processed in real time. So it's integrated with the other services of the Oracle Cloud, such as the identity and access management, the object storage, the OCI data integration that we will see later on. And also it has an interesting feature, which is the SQL endpoint. So basically with the SQL endpoint, you can target all of the data residing in your object storage. So moving forward, another interesting component which makes sense to collocate with your big data service is the OCI data integration. So what is OCI data integration? Basically, it's a cloud native ETL tool that is, it has a user interface which is completely graphical. So you will just have, drag and drop. It's intuitive. You don't have to write a single line of code. And in terms of model, it's basically your bill will depend on the amount of data that you process. And yeah, this is how it works. And finally, apart from being an ETL, it also comes with an orchestrator, which is fully integrated with OCI data flow. So the tool that we have seen just before, the managed version of Apache Spark on the Oracle Cloud. And this will unlock other possibilities that we will see later on with the second demo that I have prepared for you. So moving on, we also have another service that you can position to collocate it with your big data service is OCI Data Science. Again, it's a service that is fully managed, and it is built, from the ground up, keeping in mind the needs of data scientists. So basically, what the data scientists need to build, their model, train those models, deploy the models, and make sure that they are able to collaborate amongst themselves. So again, this one is based on Jupyter Lab notebooks. So it comes with all of the open source technologies. There is no restriction to that end. You can access all of the libraries that are available usually in the open source environment. But what it brings in here is the infrastructure side. You have a wide range of compute chips that you can choose, including NVIDIA GPUs when you want to train your model that will have, let's say, that will be based on image detections, for example. And since you can deploy the training and let's say segregate the training and the deployment, you can choose to go with a specific shape that will improve the training of the model in the sense that it will go faster. And then when it comes to deploying, you can choose to go with another shape. This service is also coming with machine learning operations, so MLOps capabilities, in the sense that you have automated pipelines. It helps you with the model deployment and monitoring the model. And again, as said before, since it has been built with data scientists in mind, you have the ability to collaborate with the model catalog. And so another service that you can position here is the data catalog. So basically, in short, what this one does is that it allows you to actually retrieve all of the technical data of your data asset wherever it resides, be it the object storage, be it your HDFS, or even the Hive metadata stores. And apart from retrieving this technical metadata, you can position business information next to that, and it comes with a browser where you can search through all of this data asset you have within your whole cloud environment. So about the identity and access management, so basically the idea here is to have a tool that is able to to do authentication and authorization when it comes to accessing your data or your data platform in general. So here we have the OCI identity and access management, which have integration with all of those various tools that we have seen. So you can address the data integration layer, the storage layer, the processing layer, and also the access layer. So moving forward, here we can discuss about our third option when it comes to how to modernize your data lake. So in this case, we want to target exactly the best of breed cloud native components that you can find on the Oracle Cloud, and without having to reuse some components that you have before. So basically here you can see on this diagram, I have many components that I have just discussed before, where in the second option, the refactoring, you will choose to collocate those with your big data service. Here, you will not follow that approach. You will, out of the box, select the different components that you need. So something important here is that you don't have to replicate the data. So basically, if your data is in object storage, for example, you don't have to copy it into your database, because your database is out of the box integrated with your object storage, and you can query directly the data in there. If you don't want to position a database in between the two, you can rely on the SQL endpoint and target your data directly. You have also the Cloud SQL also that can come with your big data service and so on. It has a focus here on data governance. So that's why here we have this tool. So this is an additional tool. It's actually the tool that I will demo to you, and it's still in limited availability. And this will allow you to have an extra layer of data governance that's its main value proposition. So basically, important thing to recall here is that you go on this platform and you cherry pick the components that you need, and you have you take advantage of the cloud benefits in general. You know, decoupling the compute and storage. You have a variety of compute shapes. You have managed services. You have auto scaling, which can be vertical or horizontal. And in general, the business model is very relevant. So if you are processing data, how your bill will depend on basically the amount of data you process. If you're storing data, it will depend on the amount of data you're storing and so on. So the platform is completely modular and it's interoperable with other cloud service providers because it uses open standards. And so this is it. So this new service that is actually that will help you to add an extra layer of data governance to your data lake is called OCI Data Lake. And so it's out of the box integrated with other services, and directly from your OCI Data Lake, you can manage the access to the data that resides in the data lake or the data that has been mounted to the data lake. And also you can manage the access to the services that actually process the data or allows access to this data. So without further ado, I will move on to the demo and what this flow will look like. The demo flow is basically that I have raw data that will reside in object storage. So I will mount that raw data, I will process the data and store it back into the OCI data lake. And I will call that the silver zone. So basically I will have a bronze zone, coming from the object storage, and a silver layer coming or that will reside in the data lake in between the two. I will use my data integration layer to ingest this data, and at any point in time I have a governance layer that is applied, and I will have a MySQL endpoint where I can query my data. So I hope we're not too short in terms of time, but here we go for the demo. So basically, to access your data lake, you go back to the same place, Analytics and AI, you under data lake, you select data lake in here. So data lake, as I said, this is still in limited availability. So this one will not show up on your screen if you try it. However, since we are hiring volunteers, do not hesitate, reach out to us. So the data lake services, here I have the list of my data lakes, and when you want to create a data lake, it's quite simple. You just click on data lake and you enter a name of your data lake. Something important to remember is the prerequisite in terms of identity and access management policies that you have to define. So I will refresh this page. See while it loads. It's faster this time. So, okay. So for the purpose of this demo, I have already provisioned the data lake. I called it OCI data lake, just to be original. So in here we have, on the welcoming page, we have this dashboard where we have an assessment of all of the data that resides into our data lake. So basically here I have 2 schemas, I have 3 tables, I have 6 roles, and I have extra information in there. So just to give you an overview of the data, when I go into schemas, so as I said before, I have data residing in object storage that I can mount into my data lake. So if I open this data is the bronze data, and just to show you, I will go back to my cluster or my bucket, my object storage bucket to show you where the data is coming from, this raw data. So these are basically CSV files that are named employee 123, and basically I will rely on the naming pattern to retrieve this data. Okay, while it loads, let's go back here and open the bronze zone. So here I have opened my bronze zone, and we can see these are the data that I have mounted from my object storage bucket. And let's go back to this bucket. So we have it here. The bucket is called external mount, and it's the exact same data. So I'm actually not copying the data into my data lake. I'm just mounting it. So basically attaching the bucket to my data lake. So the data resides in here. And the benefits of this is that you will be able to apply a layer of data governance on top of this data, even if it's physically residing in your OCI object storage bucket. So this is the first model of the type of data that you can store. The second model, it is a model that will be more of a database model, in the sense that you have schemas. So just as you will do with a database, you select your schema and you can add some properties, and these properties will be accessible to your data catalog when you want to research your data. So let's open this silver schema. So in my silver schema, you can see we have tables and views. So basically here I have a managed table. So what does it mean? It means that my table is directly into my big data, my OCI data lake storage environment, and it's being managed by my lake. So apart from this table, I can also create views. So let's see how we create tables. So basically you give it a name. I will call it my table. So here I select if these are managed table or not. By managed or not, it means the table is directly within the OCI data lake, or it's coming from an external sources. So here, if I choose external source, it means I will have to define, let's say, the object storage bucket, for example. So moving forward, you have to select the data format. So in my specific case for this demo, it's mainly CSV files, and you have other options such as Delta, Parquet, and so on. And since it's basically a table, a database table, so you have to specify your columns and choose the type of data that you have in there. So yeah, this is how you create your tables. And again, you have views that you can create based on those specific table. If I click on this here, you will see that it's just a query to create a view. So going backwards, I will now explore this data integration feature. So basically, as you can see, you have access to OCI data integration directly connected to this OCI lake. So basically on this tab, I can go to my data integration home. I will open it. And I also have the ability to import data into my data lake. And I can also have an orchestrator. So basically it's with this orchestrator that I can add my OCI data flow, my OCI data science. And you can process all of this in a coherent way. So you don't have just an ETL, you also have an orchestrator. So going to my OCI data integration that is integrated with my OCI lake. So while it loads, so yeah, because we're a bit short in time, I will just open directly the data flow that allowed me to create, to move my data basically from this bronze zone to the silver zone. So basically how I'm processing those CSV files. So here, as you can see, I have my data asset and it's the source. While it loads, what I've done here is to take all of those files, transform them a bit, and then split them based on the employee region. Those are employee data. So here, as you can see, my data asset is bronze. It's residing in my object storage bucket. And I'm relying on a naming convention pattern here. If my file starts with employee underscore, then select it. And then I split those data based on employee region. And here we can see that the target is a schema. It's here, it's my silver data, and it's a schema. So it's not an external mount in the sense that it's managed by my OCI lake. And this is the name of one of the three tables that I have chosen. So after I run this one, it will create my three managed tables that you have seen just in here in the silver zone. So yeah, as you can see, I have these three tables: employee Midwest, employee South, and other regions. So going back to my OCI data lake, here I can show you this one. It's the data catalog. So basically when you're provisioning your data lake, you have to choose which data catalog and data integration workspace you want to integrate it with. So basically with this data catalog, I have visibility on all of the data residing in my data lake. And then finally, we have these roles. So how to create a role? The role is something that is basically integrated with your data and from where you can manage the data access. So here I have created this role for my data scientist, and I have assigned it some level of permission, and I can assign the role to another user. So I will not do that in here. And basically, I can go back to my schema and show you how this data governance is actually being applied from this data governance. So I will go back to my view. It's here that I have assigned a privilege. So here, manage permission. So basically, this is a view that I have created, and it can read through all of the employee data. And the idea here is that I want to assign a select rights to my data scientist. So here we can see I have assigned the data scientist to this role. Okay. So I can edit this. And basically here I have selected this, the name of the permission. It's the view name employee all. And I can choose to either assign the permission on the view level, so allow, select, alter, drop rights, or I can go on the column level. So I can say, okay, I want just to grant a select permission. I can say, okay, only these columns that I list here will be visible to my data scientist. Basically, if you say okay, then it will restrict the amount of data that your data scientist will see. So going backwards, I want to show you something also. It's the SQL endpoint. So basically, once your data is residing into your data lake, do you have the ability to query all of this data? So the short answer here is yes, in the sense that you can assign a SQL endpoint, and this SQL endpoint is linked to the OCI data flow, and you come here under data flow, SQL endpoint, you can see here. So you assign a name, and then you choose the type of compute resource that will, be provisioned, and from where you will query all of the data residing in your data lake. So as you can see, it's all of the compute shapes that are available for your big data service as well when you want to provision nodes or nodes in general. Yeah. So for the purpose of this demo, I have the SQL endpoint for the data lake. And again, in terms of connections, how does it work? We can see that we can use this SQL endpoint to run analytics query from, let's say, Oracle Analytics Cloud on data residing on the data lake. So it's not exclusive to Oracle Analytics Cloud. It can also be for Power BI, for Tableau. And in general, any, let's say, any tool that can support or supports JDBC or ODBC drivers will be able to reuse the SQL endpoint to access the data that is residing in your OCI data lake, or that has been mounted from the object storage to your data lake. And the security level will apply here based on the profile of the one querying the data. So one last thing to show you in here is how I can target this SQL endpoint and run SQL queries. Here I have a dbeaver, and I have created my connection. So I guess you are recognizing here this, let's say, this schema, silver zone, that we have just seen, the three tables that I have, let's say, where I have ingested data from this bronze zone. We have them in here, and we have the view on which I have granted access to our data scientist. So if I run this one, I will have access to the view. So why is it working? And I don't have the restriction that I have applied to my data scientist. It is because I'm connecting as admin here. So this is it about the short demo I have prepared for the OCI data lake service. I hope it was of interest to you. So don't hesitate, if you would like to try it out, just let us know.
Fantastic. We greatly appreciate your time, and special thank you to Ismaël and Jose for this presentation. We have one final poll for you up now, and if you have any questions afterwards, please feel free to join us on the OCI forum and continue the discussions there. We hope to see you next time. Thanks again for attending.